Welcome to the shop course on welding fundamentals and key terms. Next up is welding positions. The welding position has to do with the orientation of the root and the face about the weld axis. And this is an important consideration for welding because gravity pulls on the weld pool based on the orientation of the weld. In this picture, a groove weld is shown in the flat position, or what we call the 1G position, and 1 means flat and G means groove. This is the easiest position for welding because gravity pulls evenly in a normal, predictable direction. Note that in the 1G position, the face or cap of the weld is directly over the root. Moving to the horizontal or the 2G position, you can see that the weld axis is now horizontal and the cap is no longer directly over the root but off to the side at 90 degrees. The vertical position or the 3G also includes up or down, and on sheet metal, 1/8 of an inch or less, or when we've qualified the weld accordingly, we can usually go vertical down. However, vertical down presents an opportunity for lack of fusion, especially on thicker materials. So anytime we're welding on plate material or material thicker than 1/8 of an inch, we try to go vertical up. This puts more heat into the weld as heat does rise and decreases the chance for lack of fusion. Moving on to the final plate position, we see ourselves at overhead or the 4G position, where the root is directly above the cap or the face of the weld, almost exactly the opposite of a flat or 1G weld. These welds are challenging because the gravity pulls on the face of the weld, and if your weld pool is too large, gravity is going to pull that right down onto your welding shield. The two remaining positions are pipe-specific positions. 5G involves a fixed pipe with a horizontal axis, meaning that the weld is in the vertical axis, and 6G is a fixed pipe at a 45-degree axis. And this is a very challenging weld to make because you're always moving in a different direction. Now, fillet welds put a little wrinkle in the whole weld position thing. In the case of this weld, you might assume that it's 1F because the plate is flat on the bottom and the other plate is perpendicular, sticking straight up in the air. However, you would be incorrect because this actually demonstrates a situation where the face of the weld is off to the right, in this case, of the root and not directly above it. So that means this is a horizontal weld and not a flat weld. In fact, if we wanted to see a flat weld, we would have to turn the plates on a 45-degree angle so that the face of the weld is directly over the root. It's typically easiest to get good weld quality and appearance in the flat position. Flat welds tend to work with gravity. The face of the weld is directly over the root and gravity pulls evenly on the entire weld bead. Welding out of position can be challenging and is problematic and prone to issues. And while we have to do it, this takes more time and overall is less efficient because gravity causes profile issues because it pulls unevenly on the cap and the root. So, whenever possible, get the part in the flat position. Whether you have to move it, rotate it, or otherwise reposition it, welding flat's going to help you get better weld quality and a better weld appearance. Now let's go over some general welding terms to get you up to speed. To start with, do you know the difference between a rod and an electrode? Well, first of all, an electrode technically delivers or carries the current to the weld. It may or may not add filler metal. At the same time, a rod does not carry current and only becomes filler metal added to the weld pool. In the case of shielded metal or stick welding or gas metal arc welding, MIG welding, the electrode carries the current and also is the primary source of filler metal to the weld pool. So technically, when you're stick or MIG welding, you're not burning rod, you're burning electrode. In the case of TIG welding, or gas tungsten arc welding, the tungsten electrode carries the current to the weld and the operator adds filler metal to the puddle. Another distinction that's important to make is the difference between a discontinuity and a defect. A weld discontinuity is an interruption in weld uniformity that may or may not render the part unusable for its intended application. Examples of discontinuity begin with and include weld porosity or weld inclusions, undercut, or the reduction and erosion of base material around the weld zone where it wasn't filled in properly, reduces the cross-sectional area and thereby reduces the strength around the weld. A weld joint could also be underfilled or the weld could be undersized. Incomplete fusion is another weld discontinuity that may result in a poor weld appearance and what they call overlap, where the top of the weld reinforcement sags over the reentrant line where the weld metal joins back into the base metal. Arc strikes outside the weld zone are another discontinuity. Some welds may have more than one discontinuity. For example, a poor profile with overlap is often indicative of undercut on the top side of the weld toe. Incomplete penetration could be another weld discontinuity. And that brings us to the term defect. A weld defect is a discontinuity or an accumulation of multiple discontinuities that render the part unable to meet its intended application. And thereby, those discontinuities make that weld defective. So, while a little bit of porosity is okay, too much porosity would render the weld unusable, and that porosity would have to be removed and the weld would have to be replaced or repaired. And one discontinuity is almost always considered a defect, and that's a weld crack. Any cracking in the area of a weld or the heat affected zone could be considered a defect because they grow. The next topic of discussion is welding symbols. These are graphical representations used to communicate weld requirements and specifications on a print or assembly drawing. A welding symbol includes the following: a reference line with a weld symbol above or below the line, an arrow line pointing to the joint where the weld should take place, and a tail that might be used to provide supplemental information about the welding process or finishing requirements. Now, it's important to note that if a weld symbol is placed below the line, that indicates the weld should take place exactly where the arrow is pointing, on the arrow side of the joint. You can see here that if the fillet weld symbol was placed where the X is, below the reference line, it would indicate the weld should be made exactly where it's drawn. On the other hand, if the weld symbol is placed above the reference line, that indicates that the weld should take place on the opposite side of the joint, as indicated here, where the weld is illustrated. Now, weld symbols and welding symbols are more advanced topics that are often associated with formal documentation of the welding process and or the assembly drawings. And as a result, they're slightly beyond the focus of this course. But if you're interested, you can see examples of groove, non-groove welds, and supplemental symbols in the welding guidebook.